Hello everyone, this is NagaLakshmi Devi, Assistant Professor, Department of Freshman Engineering, IARE, Hyderabad. Today's topic is Cauchy's integral formula. Cauchy's integral formula. Now the statement is let F be analytic in a simply connected domain D, and let C be the simple closed contour lying entirely within domain D, if Z0 is any point within C. Now integral over C, here it is there, the circle C, then the Cauchy integral formula becomes f of Z0 equal to 1 by 2 pi I integral over C f of Z by Z minus Z0 dz. This is the final formula of Cauchy's integral formula. Now similarly generalized Cauchy's integral formula is there, that is f power n of Z0 is equal to n factorial into 2 pi I into integral over C f of Z by Z minus Z0 to the power of n plus 1 dz. These have only two variations are there. Now first this is n equal to 1 here, it is n equal to n, some values 2, 3 like that. Now here n factorial, it is now here it is 1. Now here Z minus Z0 to the power of n equal to 1 here n equal to n plus 1. These are the two differences. How we recognize this one means, here to the power of something is there, that is Cauchy's integral formula. If power of something is there, here power of 1 is there, it is Cauchy's integral formula. Power of is something, that means 2, 3, 4, like that, that is generalized Cauchy's integral formula. First we are discussing about the Cauchy's integral formula. Now here notice if A and B are 2 points in a region R, and f dash of Z equal to f of Z, there is this one, then integral A to B f of Z dz equal to f of B minus f of A. Now integral over C means the given limits are 0 to 2 pi. If the limits they are given, no issue. If they are not given any limits, we are considering 0 to 2 pi. Now here also the range is compulsory. Here within the range, outside the region or inside the region. The given function inside the region, the final function is 0. The given determinant value is outside the region, we get the solution. Proof of the Cauchy's integral formula. Let f of Z be analytic inside and on C. This one. Now f of Z by Z minus Z0 is analytic inside on C. Expect at Z equal to Z0. We are expecting this one. Z equal to Z0. This one is also, we are considering Z and this one is Z0. Now hence draw a small circle in C1 with the center as Z minus Z0 and radius rho as shown in figure. This is the figure. Now f of Z by Z minus Z0. Sometimes they are using Z minus A also. Now here it is A equal to Z0 is analytic in the multiply connected region bounded by the C and C0. Compulsory we are connecting with the C and C0. There is a connection is there. Then it is satisfied, otherwise it is not satisfied. The connected region is compulsory, we are considering in that connected region only. Now f of Z equal to f of Z by Z minus Z0 dz is equal to integral over C is equal to integral over C1. That is also f of Z by Z minus Z0 dz. Where C and C1 are both transferred in the counter clockwise direction. Here compulsory we are using clockwise direction. Sometimes we are using anti-clockwise direction also. Here now in this method we are using clockwise direction, that is like this. On C1 only represented by C1 only, C1 region only, that is Z minus Z0 equal to, earlier we know that is R into small r into e power I theta. Now here also we are using either rho or r, that is our choice, that Z equal to Z plus, now Z minus Z0 is equal to rho into e power I theta. Now the Z equal to, now Z0 plus rho into e power I theta. We are using that one here, writing that one. Now applying the dz here, dz equal to Z0 is 0, next rho is constant, e power I theta, I into d theta. Now that totally rho I e power I theta d theta. Now, integral over C, f of z dz, f of z dz by z minus z naught is equal to integral over C is nothing but the limits are 0 to 2 pi. The limits are 0 to 2 pi. F of z. Now applying what is the function of z? Now z is nothing but z naught plus O into e power I theta. Now applying that one, f of z naught plus O into e power I theta by z minus z naught is equal to O e power I theta. Applying that one, again dz equal to O into I into e power I theta d theta. Now substituting each and every term here, we get the final solution. Now common with I into integral 0 to 2 pi f of z naught plus O into e power I theta. Here e power I theta cancelled. O and O also cancelled. Remaining f of z naught plus O into e power I theta d theta. I is constant. We are eliminating in outside. Now taking the limit as O tends to 0, we get now f of z naught equal theta, then theta is a integral part, that is the limits are 0 to 2 pi. Now 2 pi I into f of z naught. Now this is the condition. Before, now this is nothing but only here f of z naught is remaining that part is only f of z d theta. Okay, now that is why I am writing here. This is converted into totally integral I into integral 0 to 2 pi f of z naught into d theta, either z or z naught. Now that is written as f of z naught into integral of d theta. Integral of d theta is nothing but theta. The limits are 0 to 2 pi. Now applying that one, I into f of z naught into 2 pi. Now totally 2 pi into f of z naught. That is the final condition. Now how we get f of z naught equal to this one means like this. Integral over C, f of z naught is equal to 1 by 2 pi I cross multiplication. Now cross multiplication here, that one we get 1 by 2 pi I f of z naught by z minus z naught equal to dz. That is the final solution. This is Cauchy's integral formula. Now proof also is very simple one. You can see here, this is the proof of this one. Just applying z minus z naught equal to r into e power I theta, otherwise rho into e power I theta. Now substituting each and every term individually, we get the final solution 2 pi into f of z naught. Now cross multiplication, that one we get f of z naught equal to 1 by 2 pi I integral over C f of z by z minus z naught is equal to into dz. That is equation number 1. Now differentiating both sides of equation 1, we with respect to z naught, we get f dash of z naught equal to 1 by 2 pi I integral over C. Up to here it is constant. Dou by z naught into f of z by z minus z naught into dz. Now conclude that one, we get now derivative of x is nothing but 1 minus 1 by x square. Like that, f of z by z minus z naught whole square dz. Now here z naught means f dash means z minus z naught whole square. Now next step is next again derivative, we get 2 into, for example, derivative of 1 by x. That is derivative of 1 by x means x power minus 1. That is minus 1 into x power minus 1 minus 1. That is minus 1 x power minus 2. That is over minus 1 by x square. Okay. Now here, this is first derivative. What about next 1 minus 1 by x square means minus into minus plus 2 x power minus 3. That is 2 by x cube. Now we get here it is 2. Now again next one is we get 3 like that. That's why here using f dash of z equal to, now f dash of z equal to 2 factorial. 2 factorial is there. Now 2 factorial into 2 pi I, 2 factorial is nothing but 2. Next, f of z by z minus z naught whole cube dz. Continuing this process up to nth term, here 1 dash is there, square is there, 1. Now double dash means 2 factorial into cube. Now triple dash means 3 factorial by 2 pi I into integral over C f of z by z minus z naught whole power 4, n plus 1 terms. That's why we are using that one. F power n of z naught is equal to n factorial by 2 pi I integral over c f of z by z minus z naught to the power of n plus 1 dz. This is generalized Cauchy's integral formula. Now simply that is theorem and the proof also completed. Now this is final definition, that is Cauchy's integral formula. Let f of z be an analytic function everywhere on and within a closed contour integral of c. If z equal to a is any point within c, then f of a equal to 1 by 2 pi I integral over c f of z by z minus a into dz, where the integral is taken in the positive sense around c. The singular point, a point at which a function f of z is not analytic, is called a singular point or singularity of f of z. The given function f of z is not analytic, then it is called singular point. Here Cauchy's integral formula is this one. Now the next definition is singular point. If the given function f of z is not analytic, then it is called regular point or singularity of f of z. Now the first problem. Evaluate integral over c e power 2z by z minus 1 into z minus 2 dz, where c is the cycle mod z equal to 3. Now here the given function z equal to a naught, a or z naught, whatever it may be, we are considering either a or z naught. Here it is z, now it is a1, a2. Both are in the region. Mod z is 3. This is outside the region. Now here z equal to, here a1, a naught equal to 1 and a2 equal to 2 and z equal to 3. This 3 is outside the region of the given function. Then it is, we get the integral formula, Cauchy's integral formula. Otherwise, we convert into Cauchy's integral theorem, that is nothing but 0. Okay, inside the region is Cauchy's integral theorem, outside the region is Cauchy's integral formula. Now applying the Cauchy's integral formula. Why? Because the given function is outside the region. Now given integral over c e power 2z by z minus 1 into z minus 2 dz, where c is the cycle mod z equal to 3. Let we consider 1 by z minus 1 by into z minus 2. Now applying the partial fractions. Now applying the partial fractions means a by z minus 2 into minus b by z minus 1. Now LCM z minus 2 into z minus 1 by a into z minus 1 minus b into z minus 2. That equal to e power 2z, e power z. Now we consider that is 1. 1 by z minus 1, z minus 2 into z minus 1, both in cancel. 1 equal to a into az minus a minus bz minus into minus plus 2b. Now z coefficient. The z coefficients are here. The z coefficient is nothing is there. That's why 0 equal to a plus b. Now a equal to b. Now a equal to b, a equal to minus b. We get that one. And another one, constant. Constant means here 1. In left hand side 1 is there. Here right hand side is minus a. That is nothing but 1 a plus 2b. Now solving these two equations. Now we get cancelled here. It is 1 equal to over 3b. Now the simplification of this one, we get b equal to 1 and a equal to 1. Now substituting here a equal to 1 and b equal to 1, we get the total simplification. Oh, that's all. That's correct. Now a equal, just simplification, we substituting a here it is 1 and b here it is 1. Now we get the a 1 by z minus 2 minus of 1 by z minus 1. Now using partial fractions, we get the a and b values. Finally, this will be converted into this one. Now applying e power 2z in both sides, we get e power 2z by this one is nothing but e power z by, here 1 is there, 1 into this one. Now here calculate this one as simplification. What is the formula here? The formula is f of z naught is equal to 1 by 2 pi I into integral f of over c f of z by z minus z naught into dz. Here z naught equal to, here z naught value is 2. Now cross multiplicate here f of z naught, f of z by z minus z naught into dz equal to 2 pi I into f of z naught. Here 2 pi I is as it is, f of z naught value is 2, f of 2. Now 2 pi I into f of 2 means substituting here e power 2 into 2. Totally 2 pi I into e power 4 is the final answer of e power z by z minus 2. Now z equal to, the point z equal to 1 and z equal to 2 lies in C, where f of z equal to e power 2z. Now numerator is f of z. That is the formula. By z minus 2 into dz, where the final answer is 2 pi I into e power 4. Here it is 1. 2 pi I into e power 2, z equal to 2, e power 4. Similarly, and another one is there, z equal to 1. Substituting that one, e power 2 into z value is 1. Then we get 2 pi I into e power 2 into 1, e power 2. Why we get 1 minus means, here minus means here, this part in LHS is something, e power 2z by z minus 2 dz minus this one. Totally 2 pi I into e power 4 minus e power 2. This is the final solution. Now this is the Cauchy's integral formula of given function. Similarly, they are given another second problem also, that is e power 2z by z minus 1 into z minus 4 dz integral over z equal to 2. Now here one point is z equal to 1, another point is z equal to 4, but in between is z equal to 2. That means z equal to 1 has 0. Only we get z equal to 2 part condition. Outside, okay, here only z equal to 1 is there. Oh, sorry, small mistake. Now the reason is z equal to 1 and z equal to, now the z equal to 4. Here they given inside the region z equal to 2. Z equal to 2 means here 4 is longer than 2. Then z equal to 4 condition is 0. Only we get z equal to 1 condition. That is 2 factor. We are again applying the partial fractions. We get the 1 by 3 into, in area also we are 1 by 3 into e power 2z by z minus 4 dz minus integral over c e power 2z by z minus 1 dz. Now point 1 is lies inside the c, but z equal to 4 is outside the c. That's why we are not arranging this one. Just we are applying the only e power z. That is integral f of z naught equal to 1 by 2 pi I integral over c f of z by z minus z naught into dz. That is nothing but integral over c f of z by z minus z naught dz equal to 2 pi I into f of z naught. 2 pi I into, only we get this solution, not for this one. This is nothing but 0. Okay, overall 1 by 3. 1 by 3 is there, 1 by 3. Now we conclude this one. We get 1 by 3, it is nothing but 6. 6 into 2 pi I. F of z means here f of z is e power 2z. Here z naught equal to, z naught value, here z naught value is what is that one, 1 by 3 into integral over c. F of z is e power 2z by z minus 1. Z equal to 1. Total 6 pi I into e power 2. That is the final solution. Only this one. 2 pi I into, not get this one, 2 pi I into e power 2z. Here z equal to 1. Okay, 1 by 3 is there here. Total, no, 3 here. Cross multiplication we get this one. Outside c. Then total z value 1 by 3 into f of z by z minus z naught into dz integral over c equal to 2 pi I f of z naught. Then 2 pi I means over 6. 6 pi I into e power 2, z value is 1 over this one. Total 6 pi I into e power 2 is the final solution. Now another one. Evaluate. Here it is the total in power is 1. That's why it is Cauchy's integral formula. If the power is any 2 or 3 like that, that is generalized Cauchy's integral formula. Now integral over C, z square minus z plus 1 by z minus z naught dz, where C is the cycle. The first point is z equal to 1 and another point is z equal to 1 by 2. Here z minus z naught is there. They are not given any mention here. Z naught value either 1 or 2. That means we are considering total. Okay, now f of z equal to z square minus z plus 1 and consider z naught value is 1. They are not given anyone, we are considering z naught value 1. Both have same. Then since the f of z is analytic within and on cycle C, the mod z equal to 1 and it lies between z naught equal to 1 on C. Now Cauchy's integral formula, this one. Now that is, we are applying that one. 2 pi f of z is nothing but f of z naught value is 1. Now substituting that one, f of z naught means 1 minus 1, 1 minus 1 plus 1. Both are cancelled, only 1 is there. Now f of z by z minus z naught integral over C equal to 2 pi I into f of z naught. Now we are calculating f of z naught, that is 2 pi I into 1. How means z naught square minus z naught plus 1. Z naught value here it is 1. We are considering here z naught value is 1. That's why we are substituting that one. 2 pi into 1 square minus 1 plus 1. Total, these two are cancelled. We get 2 pi I into 1. Totally, we get 2 pi I is the answer. That is the answer. 2 pi I is the final answer. Now second part. Now in this case, f of z naught equal to 1 we are considering. Then another part is z equal to 1 by 2. Now that is analytic, but it is not within the region. Then it is 0. The given condition is z equal to 1, but this is a function region. Now the boundary out value is z equal to 1 by 2. That is inside the region. That's why the condition is 0. Everyone it is 0. Now similarly, we are calculating the remaining problems. Here g power 2z by z minus 1 into z minus 2 dz, the cycle over C. Now here cos pi z by z square minus 1. Z square minus means a square minus b square. That is z plus 1 into z minus 1 in cos pi z. Now the limits are 2 plus or minus I comma minus 2 plus or minus I. Now see these solutions. Already first one completed. Now here like this. Two roots are there. Two individual partial fractions. We get the y equal to 1, b equal to 1. This is the complete z equal to 3 is the outside the region. The given function values, z values are inside the region. The outside, that's the total cycle is 3. This is outside the region. That's we get the solution. That is final solution. Now the second part. Now this is the important one. F of z equal to cos pi z is an analytic solution of the given region, boundary region. Now the rectangle under the two singular points z naught equal to 1 and z naught equal to minus 1. The given value is like this. The given is 2 plus or minus I, comma minus 2 plus or minus I. Now this will be converted into minus 2 minus I in this side. In quadrant, this is positive, negative, plus comma plus, minus comma plus, minus comma minus. Now here plus comma minus. Arranging that one. Minus 2 comma, now splitting it this one. 2 plus I comma 2 minus I, minus 2 plus I, minus 2 minus 1. Now x coordinate both are positive. That's why it is here. One is positive, first one is positive, another one is negative here. Minus 2 plus I here. Both are negatives in here. This is the complete arrangement. I equal to minus 1 to 1 is a given region. Their given region is minus 1 comma 1. That's why we are arranging this one. Now the outside region is minus 2 comma 2. That means the problem is the given condition is outside the region. We get the solution. Lies inside the region in a rectangle shown in the figure. We get the solution. Now the partial fractions. Here z square minus 1 can be written as z plus 1 into z minus 1. The partial fractions are 1 comma 1, a comma b equal to 1 comma 1. We get this one. Now, in splitting into two parts, we get 1 by 2 into integral over c f of cos pi z by z minus 1 into dz minus 1 by 2 into integral over c, this one, cos pi z by z plus 1 dz. Now, applying the Cauchy's formula, 1 by 2 into 2 pi into f of z naught. Here f of z naught means cos pi z. Here z value is 1. They are given the function in z value is 1. 1 is there. That's why 1 by 2 2 pi I cos z pi. Now here it is z value is minus 1. Z minus z naught. A1 value is minus 1. That's why applying minus 1. Now we get 2 to get cancelled. Pi I cos pi minus pi I cos minus pi. That is nothing but cos pi. Total it is 0. Now again pi I cos pi minus pi I cos pi. Cos minus pi is nothing but cos pi. Overall we get cancelled 0. We get the 0. How to get 0 means like that. Outside the region, but the given function is outside the region. But final conclusion we get 0. Like this. Now, so total the solution is cos pi z by z square minus 1 dz equal to 0. This is the final solution. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.